Good afternoon, everyone. I am Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I am going to explain about the radio transmitter and the receiver. That is introduction to radio communication. It is the technology of signaling and communicating using radio waves. Radio waves are electromagnetic waves of frequency between 30 Hz and 300 GHz. These are the various types of electromagnetic radiation where first will be going with the radio waves, then microwave, then infrared, visible light, ultraviolet, X-rays and the gamma rays. Everyone will be having a various frequency ranges according to the display of this types. Uh, Basically we'll be having a transmitter and a receiver. In between that will be having a communication channel, communication that uses radio links to relay the information from transmitter to the receiver, and it is used in a radio, TV, cell phone, satellite, etc. It consists of a radio transmitter and a radio receiver that are linked by air as the communication medium or a channel. The transmitter prepares the information to be transmitted using a modulation. Sometimes will be call it as a encoding. Then in a receiver will recover and reconstruct the transmitted signal using demodulation and decoding if the signal was encoded at the transmitter. Then the antenna acts as an interface between the radio system and the channel to convert the modulated electrical signals into radio waves during transmission and from radio waves into electrical signals during reception. These are the various classification of radio waves. The first one is will be going with a very low frequency, then low frequency, medium, high, ultra high and the super high frequencies, where the frequency ranges from the kilohertz to the megahertz. These is the mechanism where signal in first transducer, and then it gives the electrical signal to the transmitter, then from the electromagnetic waves which receives the receiver, and that is being given to the transducer and finally will get the signal. This is the functional block diagram of the AM transmitter and the receiver, wherein AM transmitter will be having a power supply, and from the power supply will be giving to the oscillator. From oscillator we are giving it to the amplifier, and finally where the amplifier receives either the audio or the video signals, then to the radio antenna. That is the process of a transmitter. In the receiver side will be having the antenna first, and from antenna the input is being given to the RF amplifier, and it is given to the tuner, then to the detector. From the detector it is being given to the audio amplifier, and finally to the speaker, and finally will receives the output signal. So the difference between the AM transmitter and the FM transmitter is, in transmitter we are using only audio amplifier, but in FM transmitter we are going with the local oscillator, that is LC oscillator or voltage controlled oscillator, whereas in AM receiver we are using a detector tuner, but in FM receiver we are using a limiter and a detector. These are the various blocks which is being explained here. The audio amplifier mainly amplifies the incoming audio signals to a desired undistorted level of the amplitude. Then those outputs are being given to the power amplifier, which modulates the carrier and amplifies the modulated signal, whereas the antenna finally converts those modulated signals into the radio waves. In AM receiver, the antenna interrupts those radio waves and converts them to the electrical signals. From where that electrical signal generates a sinusoidal signal of constant amplitude with a frequency that is IF above the selected, which is also applied to the transmitter. Mixture here, it accepts RF signal from RF stage and a sine wave from the local oscillator. It mixes them to produce a new set of frequencies, which includes the sum and the difference of the two frequencies. Here the audio amplifier which demodulate the signals to derive the loudspeaker. loudspeaker, it converts the converted amplified audio signals into the sound. The same process is used here in the FM transmitter. Instead of that, we are going with the LC oscillator and the frequency multiplier. Here frequency is being multiplied in order to convert to the narrow band FM to the wide band FM. And in FM receiver will be using limiter, which makes sure that the amplitude of the FM signal fed into the FM detector has a constant amplitude. This is the various parameters which is used to characterize the radio communication waves, that is sensitivity, selectivity, fidelity, signal to noise ratio, etc. These are the various applications of radio waves. The assessment define what is meant by intermediate frequency and mention the applications of the radio waves. Thank you.